Dear children, today we are going to study the chapter Earth as a Planet. In the earlier days, it was believed that the universe was geocentric. Geocentric means that the Earth was the center of the universe and all the heavenly bodies of the universe were moving around it. However, today it is an accepted fact that the universe is heliocentric. It means the sun is the center of the universe and other planets move around the sun. It is the only planet which supports life. From space, the earth looks blue because 70% of its total area is covered by water. Hence, it is also called the watery planet. The family of the sun is called the solar system. The members of the solar system are placed at a certain distance from the sun. The chief members of the solar system are the planets, the satellites that revolve around the planets, and the other celestial bodies called asteroids, comets, and meteoroids. The planets in order of their distance from the sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The shape of the Earth. The Earth is not a perfect sphere. It bulges slightly at the center and is flattened at the poles. In the olden days, the Earth was considered to be a flat disk with steep edges. People feared that they would fall off at the edge. However, later many scholars and astronomers said that the Earth was spherical in shape. Aryabhatta, the 5th century Indian astronomer and mathematician, believed in the round shape of the Earth. He said that the Earth was spherical in shape and rotated on its axis. In the 6th century, Greek philosopher Pythagoras said the same thing. Today, we have convincing evidence too that the Earth is spherical in shape. So here are the proofs to prove that the Earth is spherical in shape. First one is the sighting of a ship. While standing at the seashore, watching an approaching ship, we first of all see only its mast. Then, as it comes closer, we can see the deck in the middle, then its funnel, and finally the hull comes into full view. This can happen only when the Earth's surface is curved. If the Earth were flat, the entire ship would have been seen all at once. The second proof is the Bedford level experiment. Almost on a similar line as described above, an experiment was carried out in the Bedford level canal area in England. 3 poles of equal length were fixed at intervals of 5 kilometers. It was ensured that the poles had the same height above the water in the canal. When the poles were viewed from one end of the canal, the middle pole looked slightly higher. It could not have happened if the Earth had a flat surface. A similar experiment was in different places. It sufficiently demonstrated that the surface of the Earth was curved. The third proof is the pole star. The pole star can be seen at an angle of 90 degrees at the North Pole. It lies in the axis of the Earth and its angle decreases towards the equator. At the equator, the angle is 0. This can happen only in an arc of a circle. If the Earth were flat, the pole star would have the same height for all latitudes. The fourth one, satellite pictures. Jean-Baptiste, the French astronomer, discovered the flattening of the Earth at the poles in the 20th century, when satellite pictures of the Earth were fed into computers. Its spherical shape had shown that the poles were flattened and was confirmed. The fifth proof, lunar eclipse. The shadow of the Earth on the surface of the Moon is clearly visible from Earth during the lunar eclipse. It appears as an arc of a circle. Since the Earth is bigger than the Moon, it is rarely oriented in the same position as the Moon, but the shadow is always circular. The sixth proof, circular horizon. The view of the Earth's surface as seen from a height is circular. With increase in altitude, the circular horizon also widens. Had the Earth's surface been flat, the Earth's horizon would have been the same irrespective of altitude. In modern days, all radio waves that travel over the Earth's surface can be heard only within a certain horizon. Beyond this, the signal is not received. This is because of the spherical shape of the Earth. The seventh proof is circumnavigation by Magellan. Magellan's ship Victoria completed a round the world voyage in 1511. His ship returned to the same place from where it had started, that is in Spain. It proved beyond doubt that the surface is round. The eighth proof is sunrise and sunset. The sun rises from the east and sets in the west. Sunrise and sunset occurs at different times at different places. This is because the earth rotates from west to east, and therefore people in the east can see the sun earlier than those in the west. Had the earth been flat, the sunrise and sunset would have occurred at the same time all over the world. The last proof is the earth as a heavenly body. The earth belongs to the solar system. All planets in this system are spherical in shape. It is because of their continuous rotation. Earth, being the member of a solar system, cannot be an exception. The conclusive evidence for the proof of Earth's spherical shape is obtained from the photographs taken from the space. Having studied about the shape of the earth, let us move on to the next point, that is the earth as a planet. Earth as a planet is a round object in space that moves around the sun and receives light from it. The planets do not have light of their own. They move around their stars in a fixed path called orbits. The earth is said to be spherical, but it is not a perfect sphere. Its diameter varies at the equator and at the poles. Its diameter at the equator is 12,756 km, while its polar diameter is 12,714 km. This difference in diameter is due to the centrifugal force of Earth's rotation at a great speed, which forms a bulge at the equator and a compression at the poles. Thus, the Earth is said to be an oblate spheroid. Earth as the home of mankind. Our Earth is the only planet that supports life. Unlike other planets, it is covered with green vegetation, enormous blue-green oceans containing over 1 million islands, a large number of streams and rivers, huge land masses called continents, mountains, ice caps, and deserts. Some form of life thrives virtually in every part of the earth, from the oldest part of the poles to the warmest part of the equator. Earth has certain features that make it habitable and thus a unique planet. Some of these features are given below. The first one is distance from the sun. The Earth is at an optimum distance from the sun. It is neither too hot nor too cold. The distance between the Earth and the sun makes life possible on the Earth. If it was closer to the sun, any life present would get burnt from too much heat of the sun. If it was farther from the sun, life would freeze because of lack of heat. The second feature is the temperature. The Earth is the third planet from the sun. It has an average temperature of 17 degrees Celsius, which is suitable for life to exist. If the average temperature on the Earth's surface changes by only a few degrees, many species would perish due to extreme heat or cold. The other two terrestrial planets, Mercury and Venus, are very hot with maximum temperatures of more than 400 degrees Celsius. The remaining planets in the solar system are very cold with surface temperature below 0 degree. Venus is the second planet from the sun, but it is hotter than Mercury. This is because the atmosphere around Venus is mainly composed of carbon dioxide. The carbon dioxide produces greenhouse effect on the surface of Venus. Thus, the temperature on its surface remains very high. The Earth's atmosphere contains a very small quantity of carbon dioxide. The next feature is atmosphere. Atmosphere is the layer of air around the Earth. It is a mixture of gases like nitrogen 78%, oxygen 21%, carbon dioxide, helium and argon less than 1%. The atmosphere receives heat from the sun by solar radiation and loses heat by Earth's radiation. In this way, a balance is maintained. The Earth's atmosphere is made up of life-supporting gases like nitrogen, oxygen and carbon dioxide. Other gases include helium and argon. Ozone present in the Earth's atmosphere absorbs the harmful ultraviolet rays of the sun. The atmosphere also prevents loss of heat from the Earth's surface and helps to keep the Earth warm. Water. Water is another feature of the Earth. Earth is a watery planet with 70% of the Earth's surface being covered by water. Distribution of water is responsible for moderating the climate and surface condition of the Earth. Water from seas, rivers and lakes evaporates into the atmosphere where it condenses and falls back as precipitation. Most of the water on land flows back to the ocean. Thus, water moves in a continuous cycle the hydrological cycle as shown. There is a proper balance between evaporation, condensation, and precipitation, without which life would not be possible. Water can absorb enormous amounts of heat without causing much change in its temperature. During the day, water bodies rapidly absorb enormous amount of heat. Thus, the earth remains fairly cool. At night, the water bodies release vast amount of heat that they absorb during the day, which, along with the other atmospheric effects, keep most of the surface from freezing at night. But for the tremendous amount of water on the earth, far greater day and night temperature variations would exist. Next feature is solid crust, which is also known as lithosphere. Earth has a solid crust. Due to the weathering of the rocks, the surface of the earth has been formed, which provides soil layer essential for supporting plant life. Weathering is nothing but breaking up of the rocks into pieces or the powdery mass. Soil also provides various nutrients necessary for the growth of plants, which in turn support all forms of animal life directly or indirectly. Next one is biosphere. Biosphere is the narrow realm of contact and interaction between the atmosphere, lithosphere, and hydrosphere. Life exists within the junction of these three realms. Biosphere is a thin layer of approximately 15 km from the deepest ocean trench to the highest mountain peak. At the ground level, it extends to a depth of 3 meters below, and in ocean waters about 200 meters deep, where marine and freshwater life is found. Within the biosphere, life is found chiefly in two forms. One is the plant kingdom and the other one is the animal kingdom. Life-giving cycles. Various life-giving cycles operate in nature, balancing the factors necessary for life. The first one, nutrition cycle. The nutrition cycle represents a relationship between living and non-living things in our environment. It shows the interdependence of all living things on earth. It operates through the food chain and other processes like photosynthesis, transpiration, and respiration, etc. The living things are divided into producers, consumers, and decomposers. Plants are the producers of food through a process of photosynthesis. Energy has its origin from here. Then there are categories of consumers, that is, herbivorous and carnivorous, who live on the producers. At the top fall man, who can modify his own environment and create changes at the bottom or in the middle level of the food chain. The second cycle is the carbon cycle. Carbon is the basic raw material of all life. All living things contain carbon. The major reservoir of carbon is the atmosphere, where it exists as a carbon dioxide. Atmospheric carbon dioxide is taken by plants. Carbon is replenished through forest, burning of fuels, and respiration of animals. Any imbalance of carbon in the atmosphere heats up the earth and leads to global warming. Excessive use of gases that produce undue heat and global warming has to be avoided to maintain a healthy atmosphere. The other cycles like oxygen cycle and the nitrogen cycle emphasize the interrelationship and interdependence of all as well as non living things.